welcome to Coffee, Computers, and Beer, your daily podcast ritual.
I don't know about daily. I don't know about daily.
We'll edit this all out. I'm Keith Adams. I'm here with my old friend Julien Verlaguet. We're here to talk through Coffee, Computers, and Beer with you.
You're Keith Adams. Tell us more about who you
Yeah,
are and what you do.
I'm Keith. I'm one of these computer people we have a lot of in San Francisco, California. I had a long career as a technologist. I was I was the 20th engineer at VMware in the early aughts. Did a bunch of stuff with the hardware software interface there, then was relatively early to Facebook where I did a bunch of backend stuff, and also started Facebook AI research about 13 years ago. I'm part of the generation of people that got fired up about AI because of what was going on in computer vision back then. Then was chief architect at Slack for a bit, and these days eventually came to feel there that your investors should understand what you're building, and started a venture firm with a bunch of other remarkable people called Doublebed.
Awesome. Maybe I want to talk about myself a little bit too, since you're not asking. I'm going to just go ahead and do
Julien,
it.
and yeah, who the hell are you actually? Why are you, how did you end up on this thing? Who's this guy?
I mean, I saw some lights. I thought there might be some free food. I was like, all right, let's try this. No, yeah, more seriously, my background is in programming languages and static analysis and this sort of stuff. I worked first on critical embedded software in a different life, where I was working on programs that could not fail. I mean, if they failed, people were going to die. And that was interesting work. Then I moved to Meta, Facebook, what it was called back then. And I worked with you, Keith. Back when you were working on HHVM, I was working on Hack. So I created this language, which is still in use today at Facebook, is gradually typed dialect of PHP. And I guess that's what we are going to be talking about today.
I mean, there's already a little bit of a definition that's probably worth unpacking here, which is you
Yeah.
already said gradually typed.
Yeah.
People these days might have experience with gradual typing, but this used to be an exotic thing to explain. But what do we mean?
So it's actually funny because I think very few people know the exact distinctions between all these things. And what is interesting is when I got started on this, it was super esoteric. And now, because of TypeScript, it seems like normal, right? Like, when I got started on a hack, the idea, I remember this vividly. Like, I was in the security team back then, and in the security team at Facebook, and we were trying to find security holes within the code base, right? And so build static analysis that would show vulnerability and stuff like that. And I remember that we were running into, problems because we just didn't have access to the types. And without the types, there's very little you can say about a program statically, right? And so this idea came of building a statically typed version of PHP, which back then seemed coconut, right? And the first idea was we're going to just write the stuff that is very critical to Facebook that we need to get right. And we're going to write it in that subset, which back then was called strict mode. And I remember my manager back then was like, the HHVM team will never go for this. Never. They are like these people who live in a cave. They barely talk to people. If you talk to them, they grunt, and you're never going to get them. And so the HHVM team back then was you, Drew Prosky, and Jason Evans. And so I'm preparing my stuff, I am because the thing is, what I needed from you guys back then was I needed to change the syntax. I needed to add syntax for the types, right? And without your approval, this was just never going to work because I would have had to add a conversion layer, which would have been slow and horrible. And,
it'd have been like CoffeeScript or whatever, one of these horrible things. And by the way, if I can say from our side of things here too, like the content that's actually required in a language runtime is just to throw this stuff away. We just need to be able to parse it and ignore it, right? Like you're building an out-of-band tool that's going to care about this stuff. Exactly. It's not even like you needed us to make some sort of deep change or whatever. You just like didn't want us to be shocked when you go messing around with the grammar.
Well, the way I was seeing it is if you are, back then the HHVM team was really in charge of the language because there wasn't a language team. And so that means that every time somebody has a wacky idea about what to add to the language, I think the right instinct should be no. you know.
And I think probably the reason we had a reputation for being grunting, cave dwelling, ogres was like, first of all, partly we were, but secondly, you were not the first person to propose a static typing system for PHP to
I
us.
remember.
But anyway, well, it sounds like I'm jumping ahead here. So
No, I remember. And there was, I would say, naive solutions that were proposed before, and by people who were well-meaning but just didn't realize that there are many problems in computer science that you can solve by reinventing the solutions and rediscovering what people have done before you. And type systems is not one of them. It's just not. Like, if you go and walk in and try to think from first principles and rebuild, it's not going to work. It's not. You need to learn the theory to get this stuff right. So there are well-meaning people who are trying things who didn't realize that it was never going to work this way. So I remember one who, was explaining to me, I hope he won't recognize himself or feel offended by that. But, he's telling me, yeah, and now I'm type checking variables. I'm type checking integers because, if I see an integer, I know it's an int. And you're like, okay, what happens when it's a variable? Well, when it's a variable, I look back in the source code, and if I find the definition, then I know that, and was explaining all of this, and you're like, dude, I know what you're doing. This is not how you're going to get this to work.
yeah.
And again, this is not a dumb person. This is not a lazy person. This is just somebody who just didn't know that this is not how you get this stuff done. Anyway,
there's just like decades of stuff that like you're not gonna that smart
you're
people
not
actually
going to
know
reinvent
that you're not
by
gonna
yourself.
find from scratch, or take your whole life
Exactly.
to find from scratch. Yeah.
Exactly. So here I am thinking the HHVM team is probably going to shut down any new idea regarding the language. So I'm preparing myself for weeks. I have something that's that thick. I have every angle. So I heard that Napoleon was, when he was going into battle, he would prepare all the possible outcomes so that he would know how to react quickly. So he had a decision tree of the things that could happen and what he would do then. That was exactly me. So I have, Keith, Jason, and Drew. You're both all sitting in this room, and I'm at the whiteboard, and I'm like presenting my stuff, this grandiose thing. And it goes on for a little bit of time, like it goes on for, I'd say 10 minutes. I'm explaining what I want to do, why it matters for security. And at some point, Keith gets irritated, you get irritated, and you say, what are you trying to do? Like, well, what is this? Why are we here? What is this thing? And then I kind of stop and say, I want to build a statically typed version of PHP. And I remember your faces, all of them look at each other like, okay, 5 seconds of silence. And then in your tone, and I don't know if I got it wrong, right or wrong. You'll tell me now if I was right.
No, please.
The tone that you were like, basically you said yes, and you were like, okay, kiddo, you wanna you wanna fuck yourself, you wanna hit a wall? All right, no problem. I'm gonna watch you hit that wall. it won't be my responsibility. You wanna run and smash your head against the wall, go for it.
Yeah.
And I was very happy with that, because all I wanted was nobody to stop me doing what I was gonna do. And that meeting was important, where I just needed the HHVM team on board with the idea of modifying the syntax and throwing away whatever I was going to add to the language. And so that worked, but I have to say it was a stressful period.
No, I'm sure. And my recollection of that conversation, by the way, too, is, and this is a while ago, right? So it's possible that I'm an unreliable narrator here. My recollection of that was that, for me, that was like fifth or something in a series of people having this idea. Do you know what I mean? So there was a lot of, it felt like throat clearing when you were sort of saying like, oh, well, static types would be good, and they let you do this, and they let you do that. I was like, yeah, no kidding, they're good. So what's next? And what happened in every other instance of it was, the people I was talking to were sort of folk language designers, right? They were, people that sort of assumed, hey, I know a lot about PHP. I spent a lot of time programming. I took a compiler course. I can get something together here. And like their proposal would basically fall apart under kind of little bit of scrutiny, right? You'd sort of be like, well, what do you want to do about arrays? And they'd have some story about arrays and be like, well, what about the other kind of array? What about the third kind of array? What about the fourth kind of array or whatever? And array in PHP is this kind of weirdly flexible data structure that captures what Python people would call a list and a dict and a tuple
Flexible
and a
is an
few.
interesting way of
Right. There are these weird things that you kind of use everything for, and an array is not a very informative type and doesn't tell you anything about what you pull out of arrays. So like you need to have a story here, and you're basically the first person that like didn't kind of completely fold up their tent and be like, let me get back to you on that with that one. So I mean, our attitude was a little bit. You're right that like we were a little bit protective of the language, but it was sort of an environment where a lot of people had a lot of ideas, not all of which kind of stood up to a half second of scrutiny. And I was actually really relieved to finally talk to somebody and come out of one of those meetings and be like, this might actually work. Like it seems like you actually know what you're talking about and you're actually thinking about it. So.
Cool. Well, that's very, so it's good. It wasn't as bad as I thought then. So
No, you
to
crushed
go back
it. It was
to
incredible.
your original question, which was what is a gradually typed language or gradually typed dialect, which is what Hack is. So it's a dialect of PHP because it's neither a subset or a superset. And that's also why we didn't call it PHP extensions or PHP whatever, because calling it PHP when you're neither a superset or a subset is, I think that was my take back in the days. I got a lot of pushback from that from management. I thought it was disrespectful to the PHP community. They have a language, they have made choices. If you're going to make different choices, things that you don't want to support, or things that you want to add, and if you want to do both, you are a dialect. Like most things are going to work, but there will some things that you'll have to adapt. So it's a dialect of PHP. And for gradually typing, so the distinction is actually a little bit subtle. It has to do with, so in fact, Hack is not strictly gradually typed. So there's a distinction between optionally typed and gradually typed. So optionally typed means there is no check whatsoever at runtime, right? So I'm calling into a function that is annotated with, let's say, an annotation that says int. If I check this annotation at runtime, that's gradually typing, right? And then now past the point where I made this check, all the body of the function can be trusted with a type system, right? So that's gradually typed. Optionally typed is you completely drop the type at runtime, you don't check anything. So that's TypeScript, right? For example. And the problem with HHVM, the problem for academics. So, whenever I was presenting that work to academics, we didn't, we didn't tick the right boxes because we were neither, the way I was presenting it back then was gradually type when we can, optionally type if we must. So the typical two cases where gradual typing becomes problematic is when you have a deeply nested data structure. So imagine you have an array of something, right? And you want to check if it's an array of it, right? So there are some trick you can place when it's int. Because when it's int, maybe at insertion time, you can remember that you actually insert an integer, and then it's relatively cheap to maintain at runtime that in this thing, there's only ints, right?
Yep.
But things get really trickier if what you insert in there is more complex, right? Let's say you insert a closure. Let's say you insert a class. Let's say you insert, maintaining at runtime, what is the common interface between those things is just not feasible, right? There's going to be way too expensive. So whenever there's a boundary between something that isn't type check and something that is supposed to type check, what HHVM and Hack did was, well, if it's cheap to check, we'll check it. And if it's expensive, we're going to go like, well, you're on your own, right?
And by the way, to some extent, if I remember right, and you should, I might have the chronology wrong here a little bit too, but like we were also at this time trying to stay compatible with open source Zend PHP. I mean, HHVM was open source, but with Zend PHP, the reference implementation we were using, and they had a notion of what they called type hints, which is like not a hint at all, but was a type assertion, basically, right? So you'd have parameters, and if you mismatch the parameter at call time, it would, I believe, throw or just abort.
It
Anyway,
would
whatever.
throw, yeah, it would
Yeah,
throw.
yeah. And so we were trying to match that. We were being a little persnickety about saying, "Oh, the unit tests from Zend run exactly the right way" and things like that at the time,
Yeah,
which
yeah,
felt
that's
important to
exactly
the
right.
project because otherwise people assumed it was some wacky hack that worked on some, no pun intended, that worked on some subset of stuff that Facebook uses. So,
No,
sorry
this
though.
is exactly right. So what happened is basically what Zend had as type hints that were enforced at runtime, those were gradually typed because you would enforce them at runtime. And all the stuff we added, the generics, the closures, etc., etc., this was, although there was callable in, I
Yep.
think, in Zend types. So we would
Yeah, yeah.
check
But
that,
callable
which
didn't have. But yeah, go ahead.
exactly. So callable didn't tell you anything about the type, the parameters and whatnot. So we just checked there was a closure, but we didn't check the rest. So we basically checked at runtime what was checked by Zend, and then everything that we added was just dropped, so was optionally typed. So technically, hack is not gradually typed, and that was, a long explanation for something relatively simple.
Would it be like more precise to say that hack was at least at this time, that hack was an optional typing system for a runtime that did partially overlapping subset gradual typing? Maybe.
That could be a way
Yeah.
of
Okay.
putting it. That could be a way of putting it.
Yeah.
Although I think they did more complex things after, where they were trying to maintain the type of elements in an array or things of the
Yeah.
sort.
Yeah. Yeah.
So I don't know what the HHVM team was up to post 2015, something like that. So, it's possible they went in other directions.
And between like TypeScript and hack and analogous systems these days, I feel like kids today don't always like know what we're talking about here exactly, but it was like the kinds of bugs that, you were worried about in the security team were these bugs where, somebody passed a string somewhere that an object belonged. And because PHP sort of struggles to complete requests no matter what, like struggles to find some meaningful interpretation of the values it's messing around with, it can kind of run on for a while. Like you'd think you just crash right away, and it doesn't necessarily. And sometimes it has horrible side effects from running on for a while. And that was extremely common in a big, complicated code base like this.
And
Um,
so that's also, so this has a name, and I think you actually encouraged me to write a Quora answer about it. So, the
mm-mm.
difference between weakly typed and strongly typed. I think
Right.
there's a lot of people who are confused about what it means. They think that strong means really strong and
Yeah, yeah,
weak
yeah.
means not so much. But really, the difference between weak and strong is not dynamic versus static. So, for example, Python is strongly typed, but it's a dynamic language. C is statically typed but weakly typed. And so the difference between the two is basically in a weakly typed system, in a nutshell, the system will make conversions for you, right? So in a weakly typed system, whether it's statically or dynamically, it will say, "Oh, you passed me null, and this I was expecting a string. Surely you meant the empty string," and
Right,
just
right.
keep on going. And that was the problem with PHP. That PHP is weakly typed. PHP, that from a security perspective, is very, very difficult because you have people who write code. And let me give you a concrete example. Imagine you have a string that is very important, like it's the
Okay.
salt for a cryptographic library, right?
Right, right.
Something like that, right? And now you expose it to all sorts of users, and those users have very, very complicated code paths that can get into this library, right? And now you have one of those code paths where actually somebody is passing null, right?
Sure.
And it's not going
One
to
time in a
crash.
thousand, by the way, right? It's like
Exactly.
every once in a
Uh,
great while, this thing turns out it was nullable.
it's
Yeah,
more than once in a great while, because probably there's like 20,000 different gatekeepers in the middle, so that, depending on how we A/B testing this, depending on which path you are, so it's way less than 1 in 1,000. You will have this path where you can hit this thing with a salt that is null. and that means empty string, and that means horrible things are going to happen. Well, for an attacker, this is gold, right? For an attacker who, so let's say an attacker had access to our source code, that's exactly the kind of thing they would be after, because then they can escalate, and this is gold for them, right? So this is exactly what we were trying to close with Hack. At Hack V1 V1 doesn't even had implicit subtyping, so that's how strict it was.
Okay.
V1 was really like Hindley-Milner, and that's
was it literally Hindley-Milner? Was it literally unification?
Yeah, it was a unification-based algorithm. Wasn't exactly Hindley-Milner, but it was without implicit subtyping. So it was really very, very strict. And what I wanted was something really by the book, so that I could, go with a straight face to anybody who was using it, and say, well, you can actually trust the types that are coming out of it. And
when you say strict here, by the way, Julien, what is the relationship between that adjective strict and sound?
Okay, so
and I apologize if this is a digression
totally
here,
fine.
But this is one of the things I was curious about in the early design of this.
So sound means that you can trust the types, right? Strict is not a term that is really academically defined. This was just how we were defining things. But in our world, what it meant, so the problem with type systems is that we talk a lot about soundness, and you talk a lot with a bunch of people, a bunch of programmers who actually manipulate type systems all the time. And because they've been exposed to the very particular breed of type systems, they don't realize that they're using certain terms that in fact don't exactly mean what they think it means. So I'm going to talk about the term sound. And what sound means in the mind of the typical developer is they think that it means that the types are going to be used by the compiler to produce more efficient code. And the reason why they think that is because that's pretty much what every statically typed language does, right? Sound statically typed language does. You enforced soundness, you proved that, something is an int 64, an int of 64
I know it's a float.
bit.
I can put it in a floating point register. I can add it with floating point instructions. Let's go.
Exactly. And that's gold to anybody who's writing a compiler, right? That's what they're after. Now, the thing is, type systems, there is a very wide range of type systems. And I would say they go from, on the one hand, type systems that are completely stupid, like Bob Harper always likes to joke about it. He says, there is no dynamic language. It's a dynamic language is a statically typed language with a very basic type system. And the type system type system says everything is of type value,
PHP value,
PHP value.
That's
right. And then you can do whatever you want with it, right? That's like having if for those who don't know programming languages, that's like having a logic system where everything is true, or true implies true. And that's all the things that you can build in this logic. It's true, or true implies true. That's a lot of nice theorems you'll be able to write, right? And so, of course, with the problem with this logic, or the problem with this type system, is that, you'll be able to prove theorems very easily or enforce types very easily. But the problem is that you don't get very interesting properties, right, out of this thing. So it's very easy for me to define a type system over pretty much any language that is sound, but this type system doesn't have interesting properties for a compiler, right? And then you have, so sound does not mean strict. Strict in the non-academic sense, right? I can have a sound type system that is very, very loose, right?
It's just not very informative. It's a big chunky sets of values in each type.
Exactly. On the other hand, you have type systems that are very, very rich. In fact, so rich that they contain all of mathematics. And again, at this other end of the spectrum, most programmers have not been exposed to those kind of programming languages, right?
Although it's 2026, I'm talking in spring of 2026, And the kids today want to talk to me about lean all the time. Like it's amazing. But
This stuff is cool. This
yeah,
stuff
yeah.
is very
Anyway,
cool.
well,
And
that's nothing to do with hack, unfortunately.
no, but what's cool about those systems is that they let you, have all of maths in your type system. So I can now say, this is a function that returns, prime numbers. I can
Right,
say that, and that's
right.
cool. Now, before these kids get too excited, maybe send them my way. The
Yeah, yeah.
kids who get
I,
too.
I
So
think this would be an entertaining.
for
Some
the
of these folks
record,
would be an interesting
for the
guests.
record, I was super excited about when I learned about Coq, which now is called Rocket, I believe.
Well, they renamed it.
Yeah, they
They
renamed it
finally gave
because
into pressure, huh?
it was
Okay.
called COQ, pronounced Coq.
Why did the French programming language researchers name it COQ? This
So
anodyne
COQ,
French word for a
it
male chicken.
means it means hen.
Yeah.
And
Okay.
normally it's the symbol of France for many, many things. But it's also a very unfortunate translation in English, not
Right.
translation. It's a very unfortunate pronunciation in English
Right.
because COQ sounds like another word in to English speakers.
Which you tricksters got to watch like awkward PL researchers stumble over in
Exactly.
conferences for an entire
Exactly.
decade.
Exactly. I don't know if
Yeah.
that was the intent, but let's just say they, I think, got past the joke and
A
now
happy side effect. Okay. All right.
they are renaming it. So back then I was learning about it and I was excited about type systems because the first time I really used OCaml, what got me excited about it is I wrote a bunch of OCaml, a lot of it, and I fought with a type checker some, and then it just worked. And this was the
Mm.
first time in my life this happened.
I had this experience with Haskell in '98, by the way.
Yeah,
And
yeah.
seriously, just like we're
So
describing, like you write 3,000 lines of code and it runs the first time, and you're like, oh my god, what is this magic?
exactly. And so I had, experience with C, with Java, with all sorts of programs, a lot of Lisp, but mostly C, C++, Java, some Pascal, a lot of experience with different kind of languages. But my favorite language back then was C. And my experience with it was I write a lot of C, a bunch of C code, and then I run my program, but I run it in GDB because I
Yeah,
know
it's gonna
I
crash.
I
Yeah,
know it's gonna cycle. I'm not even
yeah,
trying to run it without GDB. I'm like, I know this is gonna crash,
yeah, yeah.
even if I'm writing something completely trivial. And the first time I get this experience where I'm like, well, wait a minute, I just wrote 2,000 lines of code. And yes, I had to fight a little bit with a type checker, but it just worked. This is amazing, And so
Yeah.
the next logical steps, I just found out about that back then. I was a student in Paris, and somebody comes along and says, you know what? Those types that you use in OCaml, it doesn't have to stop to that. We have this other system where you can get all of mathematics in it. You can describe whatever you want in those types. And
By the way, like
it's
while we're here, like when I was like a workaday C programmer, I would occasionally hear people talking about this, even after like learned a little bit of Haskell. And I'm not sure I understood quite what they're getting at. The abstraction here is basically types are just sets of values. And you could imagine an enormously more flexible language for describing sets of values and enormously more capable. So for example, like I can't say in a C++ program, maybe I can in C++26 or something, I should check. But like it's hard to say at least this returns even integers or this returns odd integers, for instance. But that's kind of a workaday thing in these more highbrow languages.
yeah, exactly. And so when I first learned about it, I stormed into the room of my professor back then, which wasn't very polite, but he was used to it. And I said, it's amazing. We'll prove everything. And so he was used to this kind of, outburst from me. So he turns
Yeah,
around
yeah.
and say, what do you mean by everything, Julien? And I'm like, I just learned about Coq. It's the best thing ever. We'll be able to prove everything. There will be no more bugs in programs. This is a revolution. And he was like, okay, again, what is everything? It's like,
Yeah,
so
yeah.
he got me thinking, but I didn't really quite get it. And it took
Right,
me a
right.
long time to actually get it. So I spent maybe a year writing a lot of, proof carrying code and this kind of stuff. And it took me a while to realize that of all the programs that we write, some of them have a clear spec, right? Like, so for example, if you're going to sort numbers, yeah, I can write the mathematical function that specifies exactly what the output should look like. So this is a really good candidate for formal methods, because once I've written it once and proven that it worked this way, it always works for this particular property. And there are some programs that are like that. So for example, compilers, especially when they target well-defined languages, is another good target where we know exactly what the meaning of the input is, what the meaning of the output is. So yeah, formalizing it makes sense, and having a program that proves that the code that we're writing is actually correct makes sense. So that's great. And don't get me wrong, I still love this stuff for this kind of stuff. But in general, most of the programs we write, what it's supposed to do is ill-defined. Like it's going to be refined all the time. It's based on, depending on what humans prefer, what the business prefers, so if I look at the ocean of code that's out there, a lot of it is ill-defined. Like, what shall this thing actually do? The ultimate answer is probably in the hands of a human being at some point. Who's going to say, yeah, I should do this or I should do that, right? And when that's the case, those formal methods, they hurt you, because, when you write a program in this kind of environment, the amount of energy it takes to write something is huge. So for example, every single loop, you have to prove that the loop terminates. Sometimes it's a huge amount of work, because sometimes it terminates for non-trivial reasons, right? And now imagine you were writing some piece of business logic, and your boss comes around and says, oh, yeah, I don't want to calculate the price this way, but this way. And it completely invalidates your proof of how the program terminates. Well, all this energy that you put into these things, proving this property or that property, proving it terminates, is all energy that will be wasted if the program needs to be modified and the program needs to be refined, right?
Right.
So so again, to go back to our initial conversations, which was,
sorry, I keep dragging us out into the weeds here. We've got a story to tell.
No, that's fine. So we have dynamically type system, which are really not saying anything interesting other than this is a value and you can compose it with other values. Good for you, they can be sound. You have extremely strict type systems, which have their own, types that are very expressive and I think are useful for some things, which the things I think that are useful at is for programs whose output is well-defined and is not going to change over time. And then you have what everybody is used to. And what everybody is used to is C#, Java, you name it. And when you say statically typed, that's what they think of. They think of Java, And I actually suffered of that with, some people within the company at Facebook back then, and I'm not going to name names, but one of the problems I faced was what we were proposing with Hack, if the dumb type system that is fully dynamic is here, and if the super strict, numbers
you can prove like
here,
number theory or whatever.
Okay, let's say C# is here. What we were offering with Hack was here, right? So we were between a fully statically typed solution and, the dumb type system where you really cannot trust anything. And the reason was relatively simple. The reason was the $1 million question you want to ask yourself when you're adding a type system to an existing dynamic language is, if I have an array of int, shall this be compatible with an array of mixed, where mixed can be anything? And if the answer is no, you're going to break a lot of code, because there'll be a lot of code out there that was written by people who did not have types in mind. and they will expect to be able to have this operation working. If it's not working, you're going to break a lot of things. If the answer is yes, and you want this to be efficient, you don't have much of a choice other than to represent the integer as a boxed integer. I mean, boxed, it doesn't have to be allocated, but you need something that,
You need a tag
says
that
what the
says,
type is
yeah, yeah.
and something with a value. Because if you don't, then you don't know how this array is going to be used later down the road. And playing that game lazily, meaning you have a more compact representation, but then you only expand it if necessary, has its other, kind of
Yep,
kind of
yep,
worms,
yep.
kind of problem.
We
And
we've
so,
tried to play these games in the runtime too, by the way, and didn't ever quite get them to pay off while I was there. I'm told that they paid off eventually, but we had a design for something called 7-pack that was like going to segregate all the type tags in the front of, in head matter for the array, and then like have sort of unboxed values that are tightly compacted in like a dynamically allocated segment afterwards, and blah blah blah. And it's like you'd come out ahead on some like memory hierarchy things. You'd come out ahead on the fact that like your heap footprint got smaller was the hope, but it was tough to kind of come out ahead in terms of how much more compute there was, but kind of packing and unpacking these little bit packed tags and stuff. And I think everybody ends up playing with this once they get aggressive with runtime implementations for languages like this.
yeah, I mean, it reminds me a lot of the kind of problems you have with persistent data structures, right? Where
Yeah.
they typically have an amortized cost that is okay because they have this one operation that run once in a while. So typically, the well-known example is implementing a queue in a purely functional setup consisting of having two lists, right? And then once you one of the lists gets empty, you invert the other and whatnot. And the trick is, it seems like a good idea until, a bunch of people ends up holding a reference to the version of the list that hasn't been inverted yet.
Right, right,
And
right.
then they all call that thing again and again and again. And these are the kind of problems you can have in these kind of setup, right? Where you think that you're going to pay that cost just once, but no, because multiple people hold references to the old version. Hack was never going to be a statically typed language in the sense of C sharp. And that, I think, was misunderstood by a lot of people in the company and made the company, go in a bunch of, I think, wasteful directions. Not bad directions, but wasteful, in the sense that a lot of people were completely convinced that they were going to compile hack the way you compile C sharp, if we kept on going at this typing thing.
Right, right.
And you're like, no, this is never going to happen. This is
Yep,
not
yep.
what this type system is. And I think a lot of it is because of a misunderstanding of this spectrum of type system that I explained to you. Had there been this understanding that there is type systems that are super precise, so precise that you can get all of maths in it, you have type systems that are completely dumb. The only thing you can say is this is a value. And then you have all sorts of things in between that would have helped a lot.
Yep, yep.
But so how did we get there? I think we started from gradually typing, what gradual typing means, and then how did we end up in this direction? I don't remember.
I mean, it's probably my fault. I asked you, I know I asked you about the difference between sort of sound and strict at some point, because
Yeah.
you're sort of talking about strict mode, which is kind of where I think that was the first design point you hit, was kind of
Yeah.
what is now hack strict mode.
Yeah. And so hack strict mode, no, what hack strict mode is today was not what hack strict
Oh, okay.
was. Hack
Okay.
strict was much, much stricter than hack strict mode today. So hack strict was really Hindley Milner on top of PHP. And the original design was to get security experts to convert the most important parts of our code base to a really strict version of PHP so that we could control it.
From your
And
perspective
then,
at this time, Julian, actually out of curiosity, just because you were actually, what you were thinking at the time, like if that was all hack did, right? If you just sort of made the strict mode thing, yeah, it's a little bit unwieldy in some ways, but it's okay because only like 10, a tenth of a percent of the code needs to be converted to this. And it gets rid of this class of security vulnerabilities. Would you have like considered that a success, or would you have did you always kind of have the ambition to incept the whole code base? And by the
No,
way, the whole code base that we're talking about here, lest we skip over some context, we're talking about, as far as I know, the largest PHP or PHP adjacent code base that's been created. At this time, it's sort of tens of millions of lines of code,
yeah,
maybe low tens. It
no,
will make it
high
into the
test.
hundreds.
Yeah,
Yeah,
it was already big. Yeah.
yeah, yeah. So very, very large program, sort of comparable to Microsoft Office or Windows or something. It's a really, really unwieldy software project.
Yeah, exactly. And so back then, I think I would have been okay with having a niche because the problem is the original impact I was hoping to have was not really working because what was happening is that we struggled to find pieces of code base that was really isolated. And so what was going on is, so, in most programming languages, um, what you have is you have a dependency system that is relatively strict, and this is really nothing to do with dynamic versus static. So, for example, if you write JavaScript, the JavaScript folks are very, very careful about the size of their dependencies because typically this is going to affect the time to load in a browser, at least when they're working client side. And the same is going to be true about a lot of other languages where, because it's going to affect compilation times, right? If I pull on a bunch of dependencies I don't need, well, now all of a sudden it takes forever to compile something simple. And so what we have a tendency to do is to split up the work into sub pieces that are independent. And we try to keep the dependency graph as a DAG as much as possible. We try to keep it as a tree or a DAG because you can have some sharing in the middle. But the problem at Facebook is that we had this thing called auto-loading. And so with auto-loading, what was happening is whenever you used a class or a function, HHVM just figured out which class or function you were talking about, and it was just going to load that.
Yep, yep. This is
It
actually a
seemed,
PHP thing, by the way. The
yeah, yeah,
HHVM implementation
yeah.
of autoloading was the PHP. We had the same idea, yet there's same weird magic methods and everything. But sorry, go ahead.
No, but I mean, it seems like a good thing because it lets the developer move faster. But the problem with it is that it's how do I put this? Uh, it doesn't force the programmer to structure their code more, right? And to keep the dependencies in a way that makes sense. And so the way Facebook ended up was a bag of dependencies. Everything was spaghetti noodles. Everything was depending on everything. And you really could not pull out a class without pulling out millions of lines of code, right?
By the way, like a not obvious consequence of this thing that we're just going to load stuff for runtime is basically figuring out the dependency of a module is like on the wrong side of the halting problem, right? The only way to figure out what this thing depends on is to compute it forward and see all the symbols it touched. And if it happens to be all the symbols in the code base, great, its dependency is everything. If it's some subset, awesome, it's some other subset, but it's going to be a dynamically determined subset. So it wasn't like you could even, it's not just that it was like intertangled and not DAG-like and mutually nasty. So it wasn't even like you could say statically, oh, look at how nasty this dependency graph
Exactly.
is.
Exactly.
Yeah.
It's complicated. And so because of that, basically it was very difficult to isolate subpart of the code base where security engineers could work on, where you could say, all right, this is a very important piece of program. Make sure that this works because it's basically impossible to identify leaves. You don't have real leaves. Like everything depends on everything and everything is pulling in everything. And so because of that, what the original intent was to support the security teams that were working with Hack and get them to work more comfortably. And so we started relaxing things, right? And so we went from, okay, this is going to be Hindley Milner, this is going to be very, very strict, and we'll be able to trust the types to, okay, we're going to let, a lot of things, go in. And eventually, I don't want to say it was a best effort kind of thing, because it was never like TypeScript. TypeScript, they made a lot of design decisions where it was unsound or out of convenience. And so we never did that except for a couple of things that were very specific. So for example, arrays, when you access an array, um, typically it could be undefined if we cannot prove that you are out of bound, right? Now, the problem is if we make you check that something is defined or not every single time you access an array, because we cannot prove that it's not undefined, basically people are going to be throwing food at your face.
Yeah.
Developers are never going to go for it. So this was one where like, okay, it's unsound, but we'll have to swallow that one. And
Yep.
it is
Yep.
what it is. And then the difference between strict and normal mode became, do we tolerate the absence of type annotations? So we considered that a file was strict if everywhere where we expected type annotations was actually annotated, and a file was partial if there was some annotations missing. And this was a drift from the original meaning of strict. The original meaning of strict was everything is annotated and all its transitive dependencies is also annotated and everything provably works,
Right. Right.
but was not usable in practice. So to answer your original question was, would I have been satisfied with, stopping there? Yes, had we had, better success with,
Hmm.
but I realized that to be more useful to those security teams, we needed to relax
Yeah.
the current system. And the moment we relax the current system, attracted other teams who were like, well, wait a minute. I hear you have autocomplete and things of the sort. And well, I miss my, Java days.
I'd like to be able to rename a method sometime this century, for instance. Yeah, I'd like to be able to do normal programming stuff.
I
Yeah.
remember diff. This was my go-to diff to explain to people why they had to adopt Hack. So that was years later, right? While
Yeah.
Hack was being mass converted in the code base. And it was a diff with all the prominent engineer of Facebook, 2010, something like that. And they're trying to rename a method, but it was a name that was very common. Maybe it was render or something like that, a
Yeah.
name that appears everywhere. And it 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 sparked a debate that lasted for a week, and in the end, they decided not to do it. Like, look, this is proof that if you need 1 week of debate of your top engineers to
Yeah. Yeah.
decide not to rename a method, you have a problem.
Yeah.
So yeah, that was interesting times.
Curiosity too. Would you have actually, if you knew with perfect certainty before doing any of this, that in order to succeed, you're basically going to have to like convert all of this, tens of millions of lines of code, convince all of these people you've never met, deal with all of these sort of, deal with years of people criticizing your baby on sort of scant information or one bad experience. Like, do you actually think you'd have set down this road if you knew it was gonna that the mission was actually to capture all of dub, to capture the whole code base?
I don't think so. I don't think so. But I think, this is the famous quote of JFK applied to computer scientists. Maybe we mentioned it in the last episode. I don't remember. But, there's this quote that says, we don't do things because they're easy. Normally, the quote from JFK is, we do them because they're hard, right?
Right, right.
But in the computer science world, it goes like, we do them because we thought they were going to be easy.
Yeah, exactly.
There's some truth to that in, the hack project. I think what I underestimated, and for good reasons, what I underestimated was how hard it was going to be to scale, and it was due to this dependency problem. Because when I attacked the problem at first, I was convinced I was just going to do what every other language does,
Right.
split it up
Make a
into
tool that takes stuff on.
libraries,
Yeah, yeah.
have a build system, have a DAG of dependencies and build it this way. And it took me a while to realize. So there was Juan Padiolo back then, who was trying to start an effort within the company to add, uh, to add restrictions to how things could depend on one another in dub. But clearly it was going nowhere. And looking, I looked at what he was doing. I think it was very good. I think it was called overlay back then. So his idea was, there's no way we're going to bring structure to dub. So what we should do is bring our own level of structure on top of the mess by using symbolic link. So the idea was, we're going to fake this hierarchy that we need with a bunch of symbolic links. And so that was called overlay. And I thought the approach was interesting, but I thought there was so little buy-in in the company that I thought this is never going to work. So the stuff that I underestimated was, when I started this project, was, well, here's a code base where everything depends on everything. And you have a bunch of PHP developers who are never going to wait for 20 minutes for their type checker to say, yes, you can try this change that you made now. But I mean, I learned a lot in this process, and especially I learned a lot about system programming, distributed systems. I learned a bunch, but it's true that so that's true. That's one dimension. The one dimension that I did not foresee was how hard it was going to be in terms of system programming. The second dimension was, I did not realize how much human friction that would get, and a lot of it was fighting with people who have emotional reactions to this kind of stuff. And some of them, I understand their point. I think they're misguided, but it doesn't mean that I don't understand where they're coming from. Like, I remember one guy vividly who, came from a company where it was all C++. And he absolutely hated it. So I actually sat down with him and got him to explain what kind of code base this was. So this was pre-C++ 11. So imagine C++ with very, very OO C++. Everything is a virtual method. Everything is new, delete, whatnot. And he was telling me, and templates everywhere. And he was telling me, I could not modify anything without waiting half an hour for the compiler. And whenever it didn't work, the error messages on those templates were just completely unreadable.
Pages and pages of garbage that you couldn't
just
interpret.
didn't know what any of this meant. And now I arrive at Facebook and I'm productive again. I get to write stuff. It actually works. I enjoy myself. I have a good time. And here you come again with those generics and all this shit that was making my life miserable. And so the reason is, from his perspective, he associated type systems to C++ because that was his experience of type systems, right? And so my job was to convince somebody like that, type systems are not all equal, and some of them actually can make you more productive. And so this was some kind of arguments that I had to deal with. I would say people who were very emotional about, hack and bringing that into their workflow. Some others were more interesting. So some others, human interactions, where I would call it plain bad faith, like people who are just against everything for no reason at all. They just don't like the idea. So I had this guy.
The thing, but there's like a broad phenomenon inside of tech companies is, like, the vast majority of things end up not working. Right? The vast majority of things don't pan out, or if they do pan out, it's sort of pretty eye of the beholder about whether they succeeded or not. And like, you can kind of arb a perception of smartness by like just bitching about everything. If everything that comes down the pipe, you're just like, that's stupid and you're stupid. That's also stupid and you're also stupid. Like, you can sort of look smart for quite a while. And some people do kind of play that game, unfortunately.
Well, I mean, the problem is, if you play that game, you're going to be right 95% of the time. And so now you could say, well, I'm right most of the time. And that's true, but all what you're doing is shooting down everything you see. And so that's why for me, in my book, the people who matter in a company or in any endeavor are the people who stick their neck out to say something positive about something that everybody else is shooting down. Those are the most valuable people, whatever you're doing, whatever you're building. So I just read a comic book recently about George Lucas and how, he was making Star Wars. And there's this scene, there's this moment where, I mean, I didn't know that, but while he was making Star Wars, basically everybody involved thought of it as a joke. Like the
Of course.
actors
Thought it
didn't
was a B
like
movie.
it.
Yeah, yeah.
Yeah, it was a B movie. Like everybody thought this was cheap, stupid junk. Everybody who was working on this project, didn't believe in it. And then he shows it to a bunch of people who are, prominent name in the industry, and pretty much all of them say it's crap and, it's never going to work. And you have Steven Spielberg, who tells him I paraphrase because I don't remember. It's something like, this is going to be one of the biggest success in the history of cinema, And so that guy
Yeah, yeah.
is fucking gold. Because
Right, right.
that's what you need. You need the guy who's going to stick his neck out and who's going to say, this is the shit. This
Yeah,
is
yeah.
what we need to do. Because saying something is crap, guess what? Nobody remembers the name of all these people who said that this movie was crap, right?
Yep,
Nobody
yep.
remembers their name, right? This is cheap. This is easy. Everybody can do it. But the people who say, this is going to work, and so for me, the people who did that for me with Hack, so it's not the same level as Star Wars, obviously.
I mean,
But
eye of the
yeah,
beholder.
yeah,
Jury's still out. We'll see what history says.
We'll see. But there was Joel Prober. Joel
Yeah, yeah.
Prober
That's right.
really, really stick his neck out for me. And he was like, back then, he's like, I really believe in this. He really pushed in that direction. Obviously, Alok Mengrajani, who was part of the project. But there was also you.
Thank you,
You
man.
motherfucker.
Well,
You
I try,
did you did stick your neck out to say, well, this stuff, we need to give it a chance and and that was precious at that time. So to go back to your original question, which was, would you have done it knowing what was ahead of you? Probably not. I would say
Yeah,
I underestimated dramatically how difficult things were going to be technically, especially on the scaling side, not so much on the language side, because this part I knew well. But then the second dimension that I did underestimate a lot was how a pain in the ass humans can be when it comes to programming languages. I've had people, who
people have
try to
strong feelings, indeed.
try to convince me that life was not worth being lived without this or that feature.
Right,
And
right,
you're
right.
like, I program every day in a language that doesn't have this feature. I'm doing just fine.
Yeah, I have friends. Yeah, exactly. I have hobbies. Like, people like me. Um, I mean, a thing that struck me about the whole hack Lang episode from the outside, the whole adventure, and I think this fulfills like my favorite technical definition of adventure, which is something you are glad you did that you would not have started if you had any clear idea of what was involved when you started it, right? I think like one of the things that jumped out at me from how you prosecuted it that I thought was really impressive was it sort of started with this basically type theory idea. It started this sort of like set of ideas that you need a very particular background that you possessed to be able to exploit. And I think most people would say like, well, okay, like I had all the good ideas, like why are these bozos opposing me? And there were at least two areas that were really obvious where you took the ergonomic complaints seriously. One was like as a systems programmer, right? That basically you needed to have what we would now call an LSP or whatever, right? That we needed to have this kind of long-lived server that would kind of pull modifications to the file system and incrementally update a model of the program instead of some big bang run end to end over the whole code base C++ compiler style thing, because as you said, nobody's going to wait around for that.
And that's related to dependencies, right? Because
Right,
everything
right.
depends on everything, you have to do it this way.
And you mentioned the problem, but I don't think you quite got to the solution. But like the I did this too, by the way. I was a C++ programmer. I associated generics with like inscrutable error messages, right? That like if you have a generic system and I have a type error now and I'm using somebody else's generic, it means there's going to be 17 files I've never seen before in my life, and the error messages are going to be about like I couldn't unify this thing in this file, and then I couldn't unify that thing in this other file because this thing in this third file you've never heard of, and so on. And then it was going to be this whole big mess. And my impression is that you sort of took that criticism really, you took that concern enough to heart to actually, I think was it 4 lines? Is 4 lines the max for a hack error message? Did you ever get to 5?
I did get to 5, but yes, I see where you're
Darn.
going with this.
But yeah, like it usually was sort of what you wished, a sane human being would say, which would be like, I can't make this work because you told me this was a vector of foo and you just stuck a bar into it and I don't have any way to turn this bar into a foo. And it was like perfectly understandable as opposed to, 14 C++ header files, that came with
Yeah, I
the
mean,
SCL implementation.
I think we need to give credit where it's due, and C++ templates came before and are doing something a little bit different. So first of all, it came before, and it came as, something on top of C, and C adds a lot of constraints to what you can do. And because it is a system programming language, in a system programming language, you typically have to specialize all the types because you don't want to. So in a non-system programming language, what you end up doing is you tend to allocate for everything. So everything is a pointer, and then everything has the same size, and it makes everything easier, right? That's what Java does, what C# does. And then the few cases where they don't do that, it's called a value class, and it's, very well identified in the programs, right? With C++, what they have to do, because it's a system programming language, they have to specialize everything because they don't know what the size of different things are going to be. So the moment you have a generic, if you want to be able to emit the code that's going to, you need to specialize the code. And this specialization process, added to the fact that it was added as a hack on top of headers and how headers work in C, made it such that it was going to be very difficult to build good error messages on top of that, right? Like I
Yep,
start
yep.
from the header system and then I just start unfolding everything. And then, you get to the end of that. And yeah, it's making sense of what happened there is going to be difficult. So let's just say that C++ generics is solving a different problem. And
Yeah. By the way,
I
like
don't,
most of my professional life was like building C++, right? Like I'm not some hater or anything. I'm just saying, like, I know what the guy you were talking to who was afraid of your error messages was complaining about. That's all.
yeah, I mean, and I understood where he was coming from too. So I was not complaining about him. There are other people who were acting in bad faith who I'll get to later, and I have some funny anecdotes there. But I don't think he was acting in bad faith. I think he was truly trying to help the company, even though I disagreed with him. So the thing with error messages that we tried to do with hack, for every single type, we keep a witness, right? So whenever, we believe that something is an int, we're going to keep a place in the source code that shows to a human being, this is an int, and you cannot argue with the fact that this is an int, right? And so what ends up happening when you have a subtyping relationship, let's say you want A to be subtype of B. So let's say you want to return something. You want to return a value. For that return to be correct, you need the value that you're returning to be subtype of the annotation that was added by the developer, right?
Right, right.
And so the error message has 3 parts. One is, why did I start the process of, checking that this thing was subtype of this? So this is going to point at the return. It says, well, you are telling me, good sir, you want to return this thing, right?
Yeah, yeah.
And then what happens is the subtyping process starts and we go check a bunch of things and we'll hit an incompatibility, right? And that's where, instead of just dumping, pretty printing the thing you're trying to return, and the thing that was annotating, we do something else. What we do, so if you pre-print both types, there will be many cases where those both types are actually very complex and it will be frustrating experience.
Right, right.
So what we did instead is we remember all the witnesses of why types are what we think they are, and oftentimes it's going to be annotations. And we point it to the user and we say, well, on this hand, you have an int, and on this hand, you have a string. And so really what we're telling to the user is we're letting him make a choice out of three options, right? We say, okay, you want to return this thing? Three options for you. Number one, you don't return this thing. If you don't return this thing, the problem goes away.
Right.
All right. Number two, this thing over there that's an int, you need to change it. It cannot
right.
be an int because it's, or this other thing over there that's a string, you need to change that, right? And what you're telling him is, your choice, buddy. It's going to be one of those three, right? We're not going to let, or a completely different change if you want, but you'll have to do that. And what's nice when you do that is that the refactorings and all the tools that we were able to do in terms of refactoring were actually really good and really fast, because what you can do now is you want to change a type, you want to change something, you first change the type, and you let the type system go point you to all the places where you have to change it. So that was the witness system. And I tried to sell it to the C++ guy, and it was difficult because the scars of C++ were deep, very deep. And the other scar was the speed. So a lot of people complained from that world that, compilation times are slow. And we built an incremental type checker where the feedback was sub 50 milliseconds for pretty much any change you were making. So all in all, we converted people around, but it took time. And so some of them were.
And I think that was one of the things, by the way, Julien, that I thought was just like an unusual experience and partly it's that we're in the same shop as your users, right? Like you are an employee of the company that is, has the users of your language there. But you actually sort of cared about this as a product and an experience and went back and changed things and invented things and had ideas that were driven by that. And from the outside perspective, it seemed like 95% of the work was that, right? It was sort of, there was this initial spark of insight and sort of sets of ideas around, how you're going to impose some order on this type chaos of PHP programs that turned out to work. And that was hard, and not many other, you sort of succeeded there where other people had failed, but you didn't sort of declare victory then and say like, oh, okay, well, here's some tools, go use them. You actually sort of sat there and watched how people were struggling with it and changed the tool in response. That sounds like an obvious thing, but it sort of wasn't always the case, especially in the PL world. I think there even these C++ people, right? Like there are many engineers who work on static languages who just the only program in their language they really work with is their compiler, right? And that's probably par for the course for a lot of these folks.
Yeah, I mean, the thing is, I never saw myself as a language guy. I always saw myself as a dev tool guy. And so what makes my eyes sparkle is to make developers more productive. And so for me, if I'm writing a tool that, is really, really cool theoretically, has a lot of good properties, but is not used by developers, then I failed my mission. I mean, it's not that I failed my mission, it's that I don't care. I could be building the best stuff in the world, but nobody cares, nobody uses it. It doesn't interest me. And you're right that in the academic world, that is not the norm, although there are exceptions. So for example, Jan Vitek, who you also know, he clearly deeply cares about this stuff, and he really wants to see whatever he builds to be used. And so that's something we have in common. Another one is Greg Morissette, who, I talked to a bunch, and he's very happy. I mean, I haven't seen him in a couple of years, but back then he was telling me, the success of Rust, a lot of ideas from Rust came from him with Cyclone. So it was academic ideas. He didn't participate in the writing of Rust or anything, but a
Right,
lot
right.
of the ideas in Rust, were started in his work with Cyclone and whatnot. And he's very happy about that. He's very happy about the fact that his ideas led to things that, and you have other people in the PL world who, unfortunately, I think don't care at all about it. So I understand where they're coming from. I think the argument that comes back all the time is, you know, look at foundational maths, and there was a bunch of stuff that we thought was not useful, and then turns out to be revolutionary 1 century later. And I hear those arguments, but the problem is a programming language is something that's meant to be used and manipulated by human beings. And if it's not a programming language. It's something else. It's an internal form. It's whatever you want to call it. But if you're going to work on programming languages and you don't care about how people interact with those languages, that's strange to me. The
Yeah,
other
yeah.
thing is sometimes you'll have a form of snobism that is like, we write those languages that are, for better people. And all those who don't understand it are just too dumb to understand the good stuff that we do. So there can be also a form of snobism going on. But in all honesty, I think I really, and I spent a lot of time thinking about these things. I really don't know what drives the adoption of a programming language at the end of the day. If I look back, it feels a bit like music, like you've got some records that just, you know, boom, they just explode. And you ask the artist, and he thinks, this is my worst song. I don't
Right,
understand
right.
what's going on.
Yeah,
And
I'd have made the third verse make sense if I realized I was going to sing this every night of my life for the next 20 years. Yeah, yeah.
exactly. And I feel like there's some of that going on with programming languages where, you've got some programming languages that are super successful, super popular, and you look at it and you're like, that thing?
Yeah, yeah.
So for example, JavaScript is a good example, right? Like I or yeah, JavaScript is a really good example. Like it's now becoming the most popular programming language with TypeScript. Now, I understand it was imposed through the browser and then people had to use it in a browser. But then who thought it would be a good idea to use that server side? And the whole argument was, oh yeah, you'll get to use the same language and the same libraries client side and server side.
Which
But you
nobody does.
don't.
Yeah,
You
exactly.
don't.
Yeah.
You never
Nobody uses
do.
it. Yeah.
So now I'm using an inefficient language server side too. And now, don't get me wrong, I think today it's actually a reasonable ecosystem.
Yeah,
Don't
yeah,
get me
very much
wrong.
so.
I think writing, your backend in TypeScript is totally fine. It's just that the evolution of all of that, if we had to rewrite it from scratch,
Yeah, yeah.
I don't think we would go down that route, right? And so if I had to, yeah, I have a hard time. And in some other cases, I totally get it. So for example, Rust, um, I get it. I understand why people are excited about it. It is really, filling a need, like we system programmers have been battling with all those ideas, especially since C++11.
Yeah,
They
yeah.
have a bunch of concepts and C++ only enforces them partially. And they want a way to program that makes all of that safe. And Rust comes in and says, I have a solution for you guys. And that's gold. It's exactly why you want programming languages. This is awesome. Sometimes programming languages are successful for good reasons that I understand, but most of the time it beats me. I'm
Yeah, yeah. I
like,
think there's
why?
network effects and weather and like just yeah, hit driven phenomena and somebody that's smart that you respect tells you about it and so you take it more seriously or whatever. It's the mysteries of influence. Well, since we hit on TypeScript here briefly, I want to share a little bit. So I actually ended up Johnny Appleseeding hack into Slack, my job after Facebook, right as chief architect at Slack for a few years. Also a big PHP monolith for the main application, having some of the problems that initially motivated hack as well. I of course said, well, there's this thing, and a few people started playing with it, and a version of the flame war that erupted at Facebook sort of ensued over the next couple of years, and over time it ended up moving to being a hack monolith as well. And I found in that time, right? So this is now 2016 to 2020. I found in that time frame, if I'm explaining hack from scratch to people, I had my routine that I'd sort of picked up from Facebook, which is like, well, when you want to do this, you do this, and when you want to express that, express that. And I found more and more of that was me saying that, and then them being like, oh yeah, like in TypeScript. Okay, right. So TypeScript, got it. Okay, so it's TypeScript for PHP, cool. And eventually I started shortening this too. It's like TypeScript for PHP, which I feel I'm doing you a disservice every time I do this, because I know that
No,
was not
no,
the chronology and was not the order
totally
of
fine.
influence here. I'm curious, like, how that lands for you. Do you know what I mean? Like, because it's
Look,
probably like the most popular language, I would imagine, that people are reaching for by default now in server projects. TypeScript.
I'm very happy. I'm very
Yeah.
happy that TypeScript is successful. I do not build things because I want to put my name on things and get people to say I was the first to do this. I don't give a crap about that. So I'm very, very happy that TypeScript is more and more popular. I'm happy that types are more popular among developers. And I'm happy that a lot of those ideas that were not started by me. Like there was, academics who were talking about this stuff. But I would say Hack was the first project at this scale, right? Like trying to get a type system on top of an existing code base that was that large. That was the first time, this was attempted. And I'd like to believe, but I don't know, I wasn't there. I'd like to believe that have, if not inspired, at least comforted, the people at Microsoft with the idea that they could pull this off with JavaScript, right?
Yeah.
So from my perspective, the success of TypeScript is great. I'm very, very happy with it. And you're totally fine explaining that Hack is like TypeScript for PHP because that's what people are familiar with. I'm not offended whatsoever. In fact, I'm a little bit proud of it. It's
Yeah.
kind of cool. Everybody knows TypeScript. So funnily enough, I just wrote with my team at Skip Labs a re-implementation of TypeScript that is both sound and incremental. That hasn't been released yet, so that's maybe for another episode. But I
Interesting.
have a lot of things to say about
Is it literally
TypeScript.
TypeScript? It's not a TypeScript-like system. It's
It
literally all of
is
TypeScript.
TypeScript, at least all of TypeScript syntax are a few things. Because we want it to be sound, there are some constructions that we cannot support. So for example, if you have eval or if you have dynamic import, like you're importing something based on some value or things of this nature. This we cannot do, but it's a very large subset of TypeScript.
Wow,
Yes, and the
interesting.
syntax is exactly the same, and it was a lot of work because
I'll bet.
there's a lot of things in the type system. I think what's nice about TypeScript is that they built a type system that is very expressive. So the language lets you express a lot of things. What I think is a little bit unfortunate, and I don't like to say negative things about this kind of stuff without having the whole context. I wasn't there when those decisions were made, but
Yeah.
I think one a little bit unfortunate thing is that you sometimes have a hard time understanding what is checked and what isn't, and
Right.
that was something that I think was a little bit more obvious in Hack, where you could actually see what were the parts that were checked and what wasn't checked.
Yeah.
Here in TypeScript, they let you write really complex types with, very powerful constructions.
Right,
But
like
then when you
ins and
manipulate
little,
them,
yeah, like all
yeah,
these operations on sets, and yeah.
when you manipulate them, you realize that there is a bunch of cases where it's not checking anything. It just tells you, oh yeah, if you tell me that this is it, then this is it.
Yeah, you're
And
the
so
boss. Let's go.
exactly. But I think so this is secondhand information because again, I wasn't at Microsoft when this was built, but my understanding is how TypeScript came to be. The idea was more to enable the kind of tooling you would find in Visual Studio, like enable autocomplete and these
Right,
kind of
right,
things.
right.
And I think they saw type checking, like the checking part, as more like a bonus. And if that's what you're optimizing for, I think what they produced makes sense. If you have a complicated type and you clearly cannot prove that it's the right type, but at the same time, you cannot really show why it's incorrect, then maybe just keeping the type around to get the autocomplete to keep on working is maybe the best path forward, right?
Right, right, right.
So they were optimizing for something else than what we were at Hack and with Hack, and so it kind of makes sense, right?
Yeah, that makes no sense. And Julien, you're a very humble guy, so I probably should have like rung this bell a little bit harder earlier, but most programming language designers are not successful. Like even professional programming language designers, the vast majority of people design a programming language where the most complicated program ever written in it is the compiler for that language, where there are never any users of the language who are sort of outside of the community of people who are interested in it for some academic reason. So like you designed a programming language that had some novelty to it, that solved a real problem and achieved industrial adoption. And I think for everybody who was around and in the house at the time, obviously created a lot of value, and that's pretty rare. And so we're kind of describing a pretty weird arc, a really weird career arc that Julien was able to walk here.
Thanks. I mean, yeah, I don't need more praises. I'm very happy with where I'm at. I'm very, very flattered that you think that this was a great achievement. I feel very good about it myself. Part of it is luck, you know.
Sure.
There was also being at the right place at the right time and meeting the right people. I mean, you know, this conversation I had with you, I think had I had it with the HPHP team, you know, because had I come, you know, a couple of years earlier, the HPHP team, when I talked about this idea with High Ping, and I think it was Williams who was working on it. What was his first name?
Mark Williams?
Mark Williams.
Yeah.
They weren't so keen on this idea, so this could have been killed, you know, from the get-go. So there's also the people who I met within the company who helped me. I mean, I mentioned Pobar, but there was others. Alok, Mengrajani played a big role.
Yeah.
And others. So there's a little bit of luck. There's a lot of good timing, you know, meeting the right people in the right place, etc. And that's also something Facebook needed at this time. So it was a good time to go after something like that. And yes, a lot of hard work, which I'm very proud of. And that doesn't change that. The other thing is building Hack is the reason why I built Skip. And it's because it was so hard to scale Hack, because Hack was a fundamentally incremental system, which led me to build Skip, because the way Hack was working was like a language server, right? You start the server, it takes in all the files, then it watches the file system, and whenever the file system changes, it takes those changes into account. And that is a fundamentally incremental system. When a file changes, you don't want to recompute everything, right? And so I built this runtime, which was basically, I wiped out the OCaml garbage collector completely and replaced it with our own system where we had a heap that was a persistent heap that would persist data long term. And this heap was reference counted, if my memory serves me well. And on top of that, we had an OCaml runtime that was working with this thing. And the problem is back then we were maintaining the dependencies by hand. And so we had basically to do the cache invalidation by hand. And so to stabilize the system, because what kept on happening was a change comes in and not everything is updated perfectly, but it still works. So the user keeps on working with it, and then 2 days later, they have an error. This method doesn't exist. When you go look at the file, clearly the method is defined, and you don't know how you ended up in this state, right?
Right.
So what we built back then was a thing where you take the code base and you dump what we called the signature. So the signature was basically the entire state of everything we thought we knew about the code base. All the types, all the definition, everything we thought we knew was in the state, right? And then for weeks, we would have daemons that would check out revisions in Git. So back then, we were still using Git and not Mercurial, that were pretty far away. And so that was actually a ton of work for the server because Git changes a ton of things and move directories and do all sorts of work, right? And then once we hit a new revision, another revision, we would dump the state again. And we would go around like that until once in a while we would go back to a state that we knew, and we would dump the state again and compare the two states and make sure that everything was the same. Right. And that lasted for weeks, for months. And there were still bugs. There was one bug, it took us a year to find it. Oh, wow. And we didn't even find it using this stack. We had to add a bunch, because it was all concurrent with a lot of, race conditions in there, that and very subtle
right,
ones.
Watchman was also new enough that there were some Watchman issues as well.
There was no Watchman involved. We built our own stuff that was actually working. And there was no need to build. There was no need to build a Watchman, but I put a tool out there that was exactly like Watchman and was actually working. And people said, we don't want to use this because it's written in OCaml and OCaml kills babies. And so that's how they ended up writing the Watchman. And it seems like I'm bitter. I'm not at all. My impression back then was, look, I have this thing, it's working, you want it, go use it. You don't want it, go write your own thing. But there was no issue with the Watchman because we were not using that. We run into a bunch of race conditions, a bunch of subtleties, and that's what led me to the desire to go build Skip. Because I thought there's a lot of tooling that we want to write today that would be awesome if it was incremental. I mean, imagine you're a C++ developer, and imagine if you had a fully incremental front end or a fully incremental linker.
How long is the guts of an LSP for C++ these days, right? Like
But I think they're still using, because they're not using Skip, they're still using very coarse-grained dependencies, and it's still pretty slow, right? While it could be much, much more efficient. So, for example, if you have a template and all the logic that unfolds the template is written in Skip, all those dependencies are tracked for free. Yeah. So, of course, if you're not careful, you end up recomputing a lot for naught because you change one thing that happened to be used everywhere. So this is not magic. You have to work on that. But at least the part that keeps track of the dependencies and efficiently only recompute the parts that are necessary, that is handled for you, right? And so that was how, banging my head against the wall with Hack for years led to the creation of Skip, which I think was worth mentioning because it was very, very painful and very interesting, but painful years.
And that does open the door for for whenever we get to talk about Skip some too. Well, thank you for telling us about the history of the Hack programming language, Julien. And if you enjoyed this, remember to smash like and subscribe on your favorite podcasting platform. This has been Coffee, Computers, and Beer. See you next time.